Again, we're just recording our presentation portion, and then our discussion will be separate. And so to start things off, I'm going to do a quick agenda review. And so I'm going to do an overview of our drought process and kind of where we are with our drought declaration as of last month, April. And then we will have Nick Bond with the Office of the Washington State Climatologist, sort of a regional climate setting, Matt Warburton with the National Resource Conservation Service on overall mountain conditions, and Nick Sutphin with the U.S. Geological Survey on stream flow and groundwater, and Amy Burke with the Northwest River Forecast Center on overall water supply forecasts, and Chris Lynch from Borough Reclamation on the Yakima project. And then we'll have time for everyone to join the discussion and talk about other conditions or concerns that folks are seeing on the ground. And just a quick review of the role of our Water Supply Availability Committee for Washington. This committee provides an important role to advise ecology on current and forecasted water supply conditions, and in times leading up to a drought declaration on if we've met the hydrologic threshold for drought conditions. I'll do a quick recap here on what that is in a moment as well. And for our meeting today, this is just sort of a quick check-in in terms of pertinent info around water supply conditions and seeing where we are in this moment in May. And as a recap, in case somehow anyone who comes to these meetings has not seen, Ecology did declare an essentially statewide drought declaration back on April 16th. And that was due to a variety of different water supply factors. It was predominantly driven by the low snowpack across the state, as well as the warm and somewhat dry forecast that was seeing across for spring and summer. And I will just note that there is this limited exception for Puget Sound areas for the cities that are served by the utilities of Everett, Seattle, and Tacoma, due to those areas having healthy water supplies from their reservoirs and having actively managed for drought conditions this spring. And just a quick review of what we mean by drought conditions here in the state of Washington. We do have this set in our statute here in Washington. And for a hydrologic threshold, that is that it means an area is receiving or projected to receive less than 75% of a normal water supply. And again, there are a lot of different factors that come into what we mean by water supply. And again, by normal, that refers to our climate normals, which right now is from 1991 to 2020, that 30-year period. And then second, we also have a hardship threshold that water users in the environment are or anticipated to experience undue hardship from these current drought conditions. And again, leading up to drought declarations, this committee advises on that hydrologic threshold. And I'll just say briefly that, again, there are a number of water supply factors that led into our drought declaration from a month ago in April. And while snowpack was a dominant factor in that across all of the basins in Washington state, there were other concerns as well around precipitation in some areas, about groundwater in some areas, and upcoming forecasts for stream flow and water supply. And the different hardships we think at in terms of that question of what do we mean by anticipated hardship. So 3 big categories involve impacts to fish and wildlife, as well as agriculture and public water systems and domestic water supply usage. And we are already seeing concerns now at this point in late May. And I'll just quickly touch on what this drought declaration means now that we have a new one in place. And for ecology, this allows us to expedite the processing of water transfer applications, as well as to open up a grant program for drought response grants to address the hardship public entities are facing from these current drought conditions. And this list here is the list of federally recognized tribes and different public entities that are now eligible to apply for our drought response grant funding. And for anyone here that's interested, those applications are now open. And this is what that website looks like. And we'll have those links in the chat later on here. But at this point, I want to turn it over to Nick Bond with the Office of the Washington State Climatologist so that we have time for any questions that come up in presentations. And I can touch a little bit more on example drought response projects at the end if we have time.
And just while we're getting loosened up here, And apologies, Karen Bambaco couldn't make it. So you guys are getting kind of ripped off, and you know, apologies, standing apologies. Anyway, yeah, as usual, we're gonna look at what's been happening and a little bit of a glance forward. So if you go to the next slide, reviewing the water year so far, and this is, of course, starting on October 1st through last weekend. It on the left are the temperatures relative to normal, with 1991 to 2020 being those the period for norms, and the precipitation at the right in percentage of normal. It's been warm and dry. The numbers in the bullet points below are just through April when we have, the monthly averages. But befitting the El Nino that we've had, it was substantially above normal temperatures, 1.4 degrees Fahrenheit above normal, and a bit on the dry side. So next slide. Let's look a little bit closer in the past. And the maps are for the last 90 days through the last weekend again, kind of a continuation of that trend. We see with the ENSO that its greatest systematic effects are late in winter, and that played out this time also. So definitely warm from the middle of February through the middle of May, and on the dry side, especially in eastern Washington. Again, those numbers are just for a couple of months, and so for not the same period as the maps. And to be sure, in the Puget Sound region, we've had some cool weather here in May, but still overall for the last few months that really matter to our water supplies, it's been on the warm side and definitely on the dry side. All right, next slide. That is all reflected in the U.S. Drought Monitor depiction for Washington State. Just gradually over time, the areas of abnormally dry or even in moderate drought, D1 with the light brown, have expanded across the state. And so that's, consistent with the state's drought declaration. Some folks get kind of confused or upset or both or something about how there can be a different depiction in the U.S. Drought Monitor versus the state's drought emergencies. But in part, that is because the Drought Monitor is always kind of looking up to the present, and we're looking forward to what our low snowpack is going to entail. All right, next slide. As we're going to dip our toes into the Pacific as usual, you can see that dash line, the equator, that cool water is starting to emerge along the South American coast and spreading across the eastern tropical Pacific. El Nino, I'm not sure if it's officially over now, but any minute it will be. And more about that in just a second. One thing I'd like to also point out is that at our latitude, or maybe a little bit south, there's a lot of warm water in the central North Pacific. And over the last month, that warmth has been kind of creeping toward the coast. Our temperatures are much more sensitive to the temperatures of our coastal waters, but they're not by any means independent of what's further upstream. So we'll be keeping an eye on that. All right, next slide. Back to ENSO. La Nina seems to be a pretty sure bet. We're just going to have near neutral conditions, it looks like, for a few months before late in the summer we'll be in La Nina territory. And so you can see then in the upper left the probabilities of the three different sort of categories for ENSO. They're going into 2025. The lower right is from the various models, their time series of what they expect the Nino index to be like. And what I think is interesting here is that the statistical models that as a group, the dark or the thick green line and the dynamical models, the thick purple line, are showing less of a less strong La Nina for next winter, fall and winter, than the actual forecast out of the Climate Prediction Center, which is more the thick blue line that's getting down into the below minus 1.0 category. And so that there's some difference in the forecast, but the idea there is a strong consensus is going to be La Nina. All right, next slide. Big deal, of course. What's our weather going to be like this summer? And as I've been talking about the last few meetings, pretty consistently, both the models and just climate trends and everything is indicating towards a little bit warmer than normal summer. But precipitation is, I would say, uncertain, and I'm a little less certain than I guess the Climate Prediction Center is. And so just my personal bias coming in there. The ensemble composite ensemble average of the North American models is shown at top for the precipitation anomalies in the summer, not showing much of a signal over Washington State, a little bit on the dry side as a group for Oregon, and especially for the Southern Rockies. If you, the little thumbnails below show the individual models comprising that ensemble, except for the very lowest right is the international models ensemble. And the reason I show this is that there's quite a diversity among the models, whether it's going to be on the wet side or the dry side this summer. So you can kind of take your pick. And in particular, the GEM 5 model has this maybe a little bit wet, while the GFDL one has this definitely on the dry side. So I'd say it's pretty uncertain, and that is reinforced by this transition we're undergoing from El Nino to La Nina. Okay, next slide. One of the tried and true techniques that forecasters use is something, a deprog DT, or how for the same verification time, how the forecast is changing as you get new information, updates, and so forth. And so here I'm employing the international multi-model ensemble and the temperature forecasts that are made by that group of models for June through August. And on the left column are the forecasts, the most recent forecast made earlier this month, with the upper left being the models as a group and the lower left being what is often considered the very best model. It's not always the most accurate, but certainly one of the most well-respected one, the ECMWF model. And on the right column is forecast for the same period, June through August, made in March. And they're relatively similar. My reading of these results is that maybe especially in British Columbia for the models as a whole, the latest runs are a little bit more emphatic about having it on the warm side. The European Center model maybe less so, but the idea that there's some real consistency here too among the model runs that gives us some confidence that it's going to be on the warm side. All right, next slide. The official outlooks from the Climate Prediction Center focusing on June through August, are shown here. Temperature in the upper left, precipitation in the lower right. Again, in a categorical sort of fashion, and not surprising for most of the country, they have it above normal temperatures. I'm kind of intrigued that they're coming on a little stronger than the models suggest in terms of the prospects for the precipitation amounts to be in the below normal category. And so despite what I'm saying, these are the experts, right? These are the guys that do it for a living. And so they're definitely going on increased odds of it being below normal precipitation across and virtually all of Washington State. All right, next slide. Give you an idea of how warm in some of the tools that the Climate Prediction Center uses in the kind of center of the distribution of the, the probability density curves or functions that they produce. You can actually look and see how warm in terms of, temperature anomalies they're expecting. And for summer, fairly modest ones, some like a half a degree to close to a degree for the state. And as you get further into fall, as La Nina's effects start becoming a little bit more systematic, even lesser so. So while it's on the warm side in the upper percentiles, right now it doesn't look like it's going to be extremely warm. So let's go to the summary slide, last one. And again, warm and dry, thanks in part, at least, to El Nino. It was a rainy, very cool day yesterday in much of the Puget Sound Basin, but for the most part, the temperatures in May have been near normal, and parts of the state actually above normal, and definitely below normal precipitation. I'm expecting a warm summer, but not to an extreme. And here with the precipitation, wow, that's a tough call. And this very last point here to add is that most of our recent summers have been drier than their 20th century averages. And that is one of the factors that certainly the Climate Prediction Center uses for good reason. And so if that tendency keeps going, then, we could well be on the dry side. And so with that, I'll close and happy to answer some questions.
Thank you, Nick. And for any questions, I want to highlight one thing that Nick said in terms of that U.S. drought monitor, which is one of many different sort of factors or data sources we look at for the drought declaration. And the piece that Nick said that drought monitor is a snapshot in time and is not forward-looking is really key in terms of our drought declaration. So those pieces around snowpack and the fact that many basins, and particularly our snowpack-driven basins, have a low snowpack, which in Washington, again, affects water supply, affects when melt is happening, the earlier melts we talked about before, or big water supply factors. I just want to highlight that because even though we sometimes use the words interchangeably, there is technically a difference in drought and water supply. And we're really concerned about water supply impacts, and that's where that snowpack piece is so important.
Yeah, thanks for emphasizing that. I just said it in passing, but thanks.
Yeah, thank you.
So it looks like there's a question from Ben. Why don't you just shout it out?
Yeah, question is asking, it looks like the climate models are going with a dry southwest U.S., potentially indicating a dampened monsoonal flow from the Gulf of Mexico. How has reduced monsoonal activity impacted Washington's weather in the summer?
Yeah, that's a great point, and something that I told myself I should mention, and I neglected to. So thanks, Ben. And some of our precipitation, actually some of our kind of most impactful weather comes the dregs of the monsoon from the American Southwest. And so I think there's kind of a double-edged sword there, because sometimes those dregs are more dry thunderstorms that ignite fires in hard to fight places and so forth. But in other cases, there's some meaningful water that can be associated with them. Certainly last summer with the dregs of Tropical Storm Hillary, that got into, well, certainly lots of rain in Idaho and parts of Oregon, but that crept into the southeast part of Washington State too. So that itself, I would say overall means kind of maybe shades are precip a little bit toward the low side. And
Mm.
if you're a fan of thunderstorms, maybe that's not good news for you.
Cool. Thank you, Nick. Any other quick questions for Nick about what he presented before we transition to Amy? Okay, I don't see any virtual or physical hands, so we will transition over to Amy. Amy, does it work for Heather to share, or did you want to share yourself?
Heather can share. She's already got it up.
Okay, great.
So yeah, there's 3 of us from the National Weather Service. Reach out to any of us, but that email there will get the whole River Forecast Center water supply team if you have questions specifically about our water supply forecasts. Next slide. I'm laughing because I just tried to change the slide myself. Okay, so looking at precipitation and temperature for the spring, which Nick just covered very well, I just wanted to reiterate precipitation has been lower than normal. Temperatures have been kind of all over the place, but overall during the month of May they've been warmer in the eastern portion of the state. I will say the first half of May felt wet and cold, and like maybe it was going to delay snowpack a little bit, but then we warmed up again. All told, the seasonal precipitation is that far right-hand map. On all these maps, the warm colors indicate below normal precipitation and warmer than normal temperatures, which we're seeing a lot of. Next slide. Okay, so the map on the left is showing the runoff at each of these river points since October 1st, the beginning of the water year. Mostly we're seeing yellows on the map indicating below normal runoff since October 1. There are some green points here and there, and then some orange points. If you compare that to the right-hand map, which is showing our April through September forecasts, you can see more pessimistic picture. So we're expecting lower than normal oranges across most of the state, counterbalanced with some yellows. And then on the far right-hand side there, we see some reds indicating much lower than expected volume forecasts for the April through September period. I will point out these are our 50% exceedance values, so we forecast a spread in each of these forecasts, and this is the middle of that spread. Next slide. This is the most depressing slide I'll show you today. So we're still on the left-hand side, back one, although snowpack's pretty depressing too. Yeah, there we go. So the left-hand side, we're looking at the forecast percent of normal again, and we're looking at that 50% exceedance forecast, the middle of the spread. Same thing on the right, we're looking at the 50% exceedance forecast, but we're looking at percentile instead of percent of normal. So essentially we're ranking it against a hypothetical 100-year record. So the reds, the deep crimsons on this map are indicating the 10th lowest percentile. So we're talking about, approaching record low flows through the April through September period. The forecasts you see here that have single digits in them. So in Northwest Washington, I see a bunch of 4s there. Those are very low. So sometimes it's helpful, statistics can do funny things. So sometimes it's helpful when flows get low or when forecasts get low to look at the percentile to see how low if you rank them. And the answer now is quite low. Next slide, please. Okay, so looking at snowpack, not to steal Matt's thunder, but yeah, I'm showing peak snowpack roughly peak, drawing this from April 3rd, was well below normal. So again, the oranges and reds on that map are indicating 75% or less normal peaks SWE at these stations. I'm sure Matt will dive in more. And then May 21st is shown on the right-hand map. The reason why I still show that SWE peak numbers from April 3rd is that at this point, the statistics can get really weird looking during the melt cycle, especially when we're far along during melt. So the current numbers kind of look all over the place. And really at this point, it matters more what we had during the peak on that April 3rd date rather than today. But still, we see that today's numbers look pretty low as well. Next slide. Just showing some of the key water supply points around the state. This is the year-to-date natural runoff. So this is the volume of water flowing through these points expressed as a percent normal and adjusted for upstream reservoir operations. So we're looking at the amount of runoff produced by the watershed rather than what water managers did with that water. Overall, we're seeing percent normal in that gray column, less than normal with the exception of the Methow. And then changes since we last met on March 27th. We're seeing significant drops in some of these runoff numbers. This is largely just driven to the lack of precipitation in the last couple months. Next slide. So we're looking at the next 10 days of precipitation forecast, which are included in the ESP10 forecasts, which I show and talk about here. I will say, in preparing for this meeting, Brent, in the wise words of Brent Bauer, this might be a little bit optimistic. We know that springtime precipitation can be somewhat overdone as it tends to be a little bit isolated, and our processes tend to smear it around a little bit more than it actually falls. However, we are seeing precipitation forecast in the next 10 days, which is good news. So that left-hand graphic shows the inches expected to fall in the next 10 days. Again, a little on the optimistic side. The middle graphic shows that same information, but as a deviation from climatology. So the white area is expected to get about normal amounts. Those yellow areas are expected to get less than normal amounts, and that green blob over sort of north Puget Sound is expected to get more than normal amounts. And that same picture is depicted on the far right graphic, which shows a percent of normal. But we'll see. I think in this case, I would remind folks that we also have an ESP0, which does not include the 10 days of precipitation and temperature forecasts. And thinking that this precipitation forecast might be on the optimistic side, I would encourage folks to take a look at that ESP0. Next slide. Showing the next 10 days of precipitation and temperature forecasts going into the model. So you can see kind of when the precipitation is expected to fall, and you can see that this is pulled as of yesterday, I believe. Actually, no, I pulled this morning. So day one is really our big day. You can see the blob in day one there at the top left-hand graphic is our blob over Western Washington. So probably the big driver in that big precipitation over that area is today. So what we're getting today is probably what we're going to get. So I would look at that forecast tomorrow after today has passed and see what it says. The other thing I'll note, the right-hand column here shows, of all these graphics, show the snow level forecast. So we're seeing it warm up there on day 7 and beyond. And I would expect significant snow melt. We're already in the middle of the melt cycle, but I would expect it to pick up then. Next slide, please. So jumping into our water supply forecasts, which are, again, are more pessimistic than the runoff year to date. So again, the map is showing that pessimism, I'll call it, with orange points all over indicating less than normal expected amounts for the April through September volumes. This gray column in the middle is showing lower than normal. I'd say well lower than normal amounts at all these key water supply points. And then that orange column there on the far right is showing decreases at all of these points with the exception of the Methow, And that increase, I looked in our model this morning, that increase has been driven by some boosting of the snowpack that we modelers did May 12th through 17th, as we noticed our modeled snowpack was falling below our observed guidance series. So we bumped that up a little bit. We'll see how that comes out in the end. Next slide. Just taking a quick tour of our monthly water supply forecast. Now that we're in the April through September period, it's sometimes more helpful to actually look at these monthly water supply forecasts. So on the y-axis, we're looking at the volume expected in each month, and the time through the water year on the x. We're comparing the observed blue bars, which indicate the current amount of observed runoff. We're comparing that to the green diamonds, which are the 30-year normal, and then also the yellow box and whisker plots, which are our forecasts. So you can see that left-hand side, the Skagit, we have accrued deficits, especially during the last couple months of April and May, or May so far, I should say. So you can see the blue bar did not reach the green diamond. That deficit is expected to be quite large in May and again in June. So that June deficit, I'm comparing that red bar, which is the middle of the road there for our spread of forecasts to the 30-year normal. And again, because I'm telling folks that our precipitation forecast might be on the optimistic side, I would trend toward the low end of that forecast spread. So this is a common pattern that we're seeing throughout Western Washington with these expected deficits, observed deficits in April and expected volume deficits through May and June, and really the rest of the water year. The bottom graphic, I just didn't want to leave the Chehalis out since it's one of our west side points. It's really a different signal because this is a rain-driven system, doesn't have the high elevation with snowpack. So we see normally the big volumes come in December and January, and those were achieved, but we are still expecting deficits for the rest of the water year. And we saw one in April still. Next slide. So those were kind of the west side key points, and these are the east side key points, water supply points. And we're still seeing a lot of the same story. So for a lot of these, I'm seeing the peak with the exception of the Walla Walla. So we're looking at the Okanaga and Yakima and Methow here. So normally May is the big runoff producer at these points, and we're expecting a deficit in May, followed by pretty big deficits in June and for the rest of the water year. And same story at Walla Walla, the signal is maybe just not as strong. Next slide. So just to wrap up, the snowpack remains below normal. Precipitation has been below normal. The next 10 days are expected to bring precipitation to Washington. I am worried that that is a little on the optimistic side. Runoff and water supply forecasts have decreased since we last met a couple months ago, and our water supply forecasts are quite low. That's all I've got today. I'll take any questions. Or if Brent and Robin have anything to add, feel free to jump in.
Great. Thank you, Amy. We've got a question in the chat, and then I have a clarification question as well. First, from the chat, the question asks, has your team looked at whether other weather models going with wetter than normal conditions the next 10 days in the same areas?
We do not. We really incorporate. Actually, that's not entirely true. We do have another product that is our HEFS product that incorporates a different weather model. So we have those forecasts available on our web. We do have them labeled as experimental. I'd say at this point they are less experimental, and feel free to look at them. So they incorporate 15 days of a different weather model. But let me make sure I answered that question. Yeah, I don't have a clear picture right now of whose forcings are producing a wetter forecast. I hope that answers your question.
Thank you, Amy. Another question I have, I know one of the questions we get is this piece about when forecasts use just the next 10 days, and then after that, the climate normals, versus when forecasts are using what we are seeing as projected for this year in the forecast. Can you clarify with what you talked about where it uses climate normals after the next 10 days?
Yeah, so all of our ESP flavors, I'll call them, we have 3. We have ESP0, ESP10, and then our HEFS forecast. So the ESP0, all of them after 10 days or 15 in the case of HEFS, use historic pairs of temperature and precipitation. So we're really only incorporating weather forecasts in the very near term future. And the ESP0 forecast doesn't even include those. So things like CPC outlooks are not included in our models. Does that clarify?
It does, and thank you, Amy. I just wanted to highlight that because that's like for colleges, one of the things too that we took into account with our drought declaration, and that piece that everything you're showing so far, indicates these lower water supply forecasts. And then to me, that's really emphasized with the fact that these models actually are not taking into account, those forecasts for spring and summer with warmer temperatures, but use climate normals after the next 10 days.
I nod my head vigorously. Yes.
Great, thank you. That's sort of letting me highlight those pieces there. Great. Any other quick questions for Amy or others from the River Forecast Center before we move to Matt? Okay, I don't see any physical or virtual hands, but we'll have time for more at the discussion time. Heather, can you go ahead and bring up Matt's slides, please?
Can you see those?
Yep, looks good.
Sweet.
All right. Hello, everyone from the eastern reaches of the Columbia Basin. I am just south of Flathead Lake this week. Apologies for any potential background noise, but we'll go ahead and get started here. Next slide. You can brush through that second slide too. First, getting to snowpack conditions. All right, taking a look first at just the statewide snowpack profile plot. The black line is the profile for 2024, and the other trend lines are for the previous 5 years and including 2015, just an exceptionally low snow year. Statewide, snowpack is 62% of normal, and it's the lowest it's been the last 6 years, and that percentile is at 26. So again, just the common sort of thing I've been saying all winter so far, just extremely low snowpack across much of Washington. Next slide, please. I'm glad Amy showed the peak snowpack map because I do not have it included here. The first map I'm showing is the date of water year meltout for the sites that have melted out so far. I want to draw your attention to sites in the Central Cascades where we've really seen exceptionally low snowpack and extremely early meltout at those sites. These are sort of lower elevation sites in the Central Cascades, but we're seeing snowpack that is melted out 40 to 50 days earlier than normal. For sites that have melted out in the northern parts of the Cascades, we're seeing again early meltout anywhere from about 15 to 20 days. Elsewhere, not as substantial early meltout, but still up to a week. And in the northern blues down in southeastern Washington, up to 29 days early meltout there. So pretty significant. Next slide, please. And I would show the onset to snow melt map. However, sort of the multiple periods of melting and accumulation at a lot of sites have sort of confused our backend algorithm. So the numbers there aren't quite right. And this is perhaps a nice disclaimer if you choose to look at that on our interactive map. I would look more towards the snowpack profile plots if you're interested in that. This next map is showing the snowpack as percent of median or normal Again, across the state, just exceptionally low snowpack, except for the regions sort of between Helens and Adams, where snowpack has fared quite well. And included with this map, I'm showing 2 snowpack profile plots just to show you some of the delay in the onset to melting or the slower melt rate at some sites, notably in portions of the North Cascades near Mount Baker, showing the MF Nooksack Snowtail site just north of Mount Baker there. A little bit of a delay in onset of melting, which is a good thing in a year where snowpack has been so poor. But of course, this isn't really helping the water supply outlook, but will provide some potentially elevated flows that are still going to be below normal, but will, I guess, help maybe somewhat. And with potential, warmer temperatures, we could see more rapid melt out, but for now that melt out the rate of melt out has been fairly normal. Next, taking a look down in the Southern Cascades near Mount St. Helens at the Sheep Canyon Snowtail site. There's the onset of snowmelt has really been delayed until about early May. There is some melting mid-April towards the end of April. But with that late season storm that provided some additional snow accumulation, we really saw a delay in snow melt, and snow melt there and at nearby sites really began in earnest towards mid-May. Again, with a rate of snow melt that's not really too far from normal or is right around normal. So that region will fare quite well in terms of stream flow and water supply, but elsewhere, extremely poor snowpack. Next slide, please. Next, getting into precipitation conditions. Next slide. Looking first at statewide water year-to-date precipitation, along with a basin map on the left. Statewide water year-to-date precipitation is at 90% of normal. Last meeting, that was 88% of normal. So not too much of a change, a slight increase, but really same picture as last meeting. Across Washington, now looking at the map, continuing to see water year-to-date precipitation deficits across most of the Cascades, except for, again, the wetter region that's been pretty consistently wetter than the rest of the state throughout the season, the Southern Cascades around Mount St. Helens and extending to Mount Adams. Elsewhere, water year-to-date precipitation is moderately below normal. There are some more near normal water year-to-date precipitation areas, such as in the Upper Columbia Basin, east of the Cascade Crest, stretching to the Idaho border. But in general, if we're looking at the Cascades and even the northern blues on the Washington side, water year-to-date precipitation has been mostly below normal. Next slide, please. Now taking a look at month-to-date precipitation, coming off a fairly dry April, except for portions of the Central Cascades in Washington, where we did see more near normal month-to-date precipitation. We're continuing to see near normal precipitation for this month in that region. But in addition to that region, also near to above normal precipitation at snowtail sites in the Southern Cascades in Washington too. For a lot of regions east of the Cascade Crest, month-to-date precipitation has been below normal, in some cases well below normal. And then on the Olympic Peninsula, precipitation this month so far has been quite poor. In addition, not to leave out southeastern Washington, precipitation there has been mostly below normal as well. And then looking up to northeastern Washington, sorry, I think I said southeastern Oregon, I meant southeastern Washington. Looking at now northeastern Washington, monthly precipitation is slightly to below normal there. Next slide, please. Now, I showed this last meeting, but showing this again, just to sort of highlight the compounding precipitation deficits that we're seeing, notably across the Cascades. And this is a 24-month precipitation. You could probably extend this out a few more months, if not a year, and still see some record lows. But, notable for this 12-month precipitation records, we're seeing record low precipitation during that period across many portions of extending from north of Mount Rainier all the way to the Northern Cascades. And of course, that has an impact on areas, regions and basins' ability to recover from drier conditions. So I think it's extremely important to show these sort of year-on-year compounding precipitation deficits that we're seeing at several SNOTEL sites in the state. Next slide, please. Now touching on soil moisture, next slide. First, showing some soil moisture at stations across the Cascades on the Olympic Peninsula. Sorry, the arrow's pointing to the wrong site, but looking at the Bucking Horse SNOTEL site in the upper left, that should be pointing to the site that's just south of the one it is pointing to. Soil moisture there, despite lower snowpack and some lower precipitation values, we've seen more near normal soil moisture really throughout the winter at Bucking Horse. And moving on to just northwest of Mount Rainier to the Burnt Mountain SNOTEL site, consistently seeing below normal soil moisture there. And then moving towards the Northern Cascades, where soil moisture, a bit of a mixed picture. If we look at our Beaver Pass SNOTEL site, soil moisture has been at record lows really since towards the end of December. And then looking at the Rainy Pass SNOTEL site, soil moisture there has been slightly below normal and more near normal recently. The reason why our profiles are cutting off at the 100 mark is that these should be viewed, these aren't calibrated to the soils at the site. So take these at a sort of a qualitative value and not a quantitative. So the period record should be viewed as relative pretty much. So, but nonetheless, more near normal soil moisture conditions at the Rainy Pass SNOTEL site. Next slide, please. Next, taking a look at some stations east of the Cascade Crests. First, looking at Salmon Meadows, the profile in the upper left. Soil moisture conditions there are below normal and have really been more below normal throughout the bulk of the spring so far. In the next, in the upper right, taking a look at the Moses Mountain soil moisture, trending since about early April towards below normal and near record lows. So drier soil moisture conditions are developing at that station and potentially in that area. Next, taking a look at Ragged Mountain in the lower left, which is a station near or right on the Washington-Idaho border. Soil moisture conditions there have been fairly variable, but right now are near normal. And next, taking a look, moving down to the Northern Blues at the Sourdough Gulch SNOTEL site. Moisture there has been declining. It was mostly normal throughout the spring and parts of the winter, but now is trending and is at period of record lows. So drier soil moisture conditions there have been developing since about mid-May. And next slide, please. In this next slide, we'll show couple of the satellite products, both NASA GRACE and the Sport Lease soil moisture products. And it's a keep in mind that this sort of the methodology for each of these products is a bit different, where the NASA GRACE relies more on surface water supplies. But let's take a look at the NASA GRACE product first. where we're seeing sort of indications of drier soil moisture conditions, mostly in the northern Cascades, stretching out east of the crest there, but also in sort of eastern central Washington and near the Idaho border, some drier soil moisture conditions. Taking a look at the NASA Sport Lease product, this has been a little bit more consistent with our site data throughout the winter and spring. Taking a look now at that product, we're seeing some drier soil moisture conditions in the northern Cascades, not as much as what the Grace product is indicating, but drier soil moisture conditions too in southeastern Oregon and in portions of the Yakima Basin as well. And the sort of drying soil moisture trend, the southeast Washington is consistent with conditions at our sites and conditions that we've been seeing in northeastern Oregon as well, in that part of the Walla Walla and the Umatilla Basin there. So more consistent, like I said, with our SNOTEL site data. Next slide. And touching on the water supply outlook, our latest was released on May 1st. So, 22 days into May, but nonetheless, we'll take a look at those forecasts real quick. The outlook across much of Washington, except for some portions in southern Washington, the southern Cascades, is below normal, with some degradations in terms of CAF in the central Cascades. And the bottom left picture shows the normal percent normal of that 50% exceedance forecast, and the map on the upper right shows the percentile, just highlighting sort of areas where water supply outlook is generally extremely poor, noting several red dots there and orange dots. Again, some portions in the very southern Cascades in Washington have a near to slightly above normal water supply outlook for the summer. And next slide, I believe that's it. Thank you.
Great. Thank you very much. Any quick questions for Matt before we jump over to Nick? Great. Thank you very much for that, Matt. I hand it over to Nick now, and you should be able to share your screen there.
All right, let me find that button. Let's see. There we go. All right, you can see my slides.
Yes, thank you.
Okay, great. Yeah, thank you. All right, good morning, everyone. Thank you all for those great updates. It's going to talk today, as usual, about stream flow and groundwater conditions as of current at our gauging stations for the USGS. 7-day average stream flow as of a few days ago. Largely normal across the state, with the exception really around the Puget Sound area being below normal and much below normal on this western part of the state. Of course, some sites in the southeast as well being below normal, and a few record lows here. Normally this key indicates low. I trying to clarify here that this means that it's essentially a record low for this day of the year. And in this case, we're looking at 7-day averages. So this is a record low 7-day average for this day of the year for a few of these sites in bright red. Looking at our 8 index gauging stations that we normally view, this reflects similar is what we saw across the state. Most of these sites flowing normal, with the exception of the Puyallup being below normal, and Hangman Creek near Spokane And as you'll see in some other future slides, that Spokane River is a little on the drier side as well. Backing up then to look at, excuse me, the last 45 days in the state. These are the percentage of stream gauges here on the vertical axis with this 50% dashed line just showing kind of that median. So ending up where we are here, so that more of our stream gauges are currently at normal or above flowing conditions, with about 25 or so percent at lower flow conditions. This is a similar plot on the right, showing essentially whether we are more on the wet or dry side. We've been kind of just skating along normal for the last 45 days with a dip there in April, where we got a bit drier, and coming back up closer to normal now in May. Looking again at the 7-day average across the whole state, now looking at the basins, we have generally similar trend of normal to below normal, with a couple of basins indicating here the upper Yakima and the Roosevelt Lake and upper Columbia being below normal and are much below normal, and even a record low for the 7-day average up there in Roosevelt. The 28-day average, so stepping back a bit into April, where we didn't actually meet, we see a pretty similar trend, but a little bit drier, with the exception of above normal here in the west, but we had some drier basins here in the lower Snake, as well as the Puyallup over here, and we still see that Roosevelt impact drier conditions. Then stepping back further, since we didn't meet in April, and just to remind us of the March, I think last meeting in March, we didn't have a full March values because the month hadn't ended. So March was a bit wetter. We had more normal conditions with some below normal, some above normal. Our April was pretty dry, particularly in the western part of the state, where we had Nisqually and Deschutes basins were much below normal, and the Duwamish as well. And if we compare then, just since we had April as a complete month, and look back at our April this year compared to last year, where we had kind of a bit more variability. Last year, we had some more basins that were below normal and much below normal in the eastern part of the state, and we had a wetter western part of the state as far as stream flow conditions at our gauging sites. And comparing that to a few of the drought years that we have, 2019, 15, and 05, we are certainly kind of in the middle of some of those, not quite as wet as 2019, certainly not as dry as 2015, with less of our basins being much below normal than both 05 and 15. Then looking again at the 7-day average, but now through this water year, comparing this to our past conditions, the black line indicating the current water year. We had that dry spell in April there, where it dipped down much below normal. We've kind of had a little bit of relief from that, and now we're skating on the edge of normal to below normal stream flow or runoff conditions statewide. And again, also to compare this is 2024 again on the right to some of these other drought years. We're certainly in a better approach, I guess, as far as stream flow with regard to the winter than we were in cases like 2001 or even 2005 and 19. We had a lot of variability here in flow, where we had some higher flows, maybe something a bit more like 2015, And so right at this time in May, we're kind of skating that lower edge of normal, similar to where we were in 01, 05, 09. This is, of course, nothing to say about projected future forecast and climate and snowpack, because all this just is a result of that. But we're certainly in a much better condition than 2015, where we were already much below normal flow conditions by this time. So the cumulative runoff hydrograph showing, the amount of stream flow that is accumulated throughout the water year. Just continue to compare this to last year, where we were kind of skating up in normal and the edge of normal through the end of the water year. We're a bit higher than that, right about the middle of normal for cumulative stream flow or runoff across the state. Now to switch to groundwater conditions at our 3 kind of reference wells here. Have these 3 plots we're accustomed to seeing, showing similar as we had that runoff plots for stream flow. We see the colors indicating the percentile of groundwater conditions at these sites. Scatter Creek well there in the west being about normal, which has been typical as of our meetings for the last couple of years. Similarly, Davenport well over to the east central part of the state being below normal. That has been typical. It was riding much below normal for a while, which has more typically been the case, but we've had a little bit of reprieve here. And then the Whetstone well over near Walla Walla, we're just kind of riding normal groundwater conditions over there. And just to kind of put some of that into perspective with regard to recent years, this is again looking at Scatter Creek in the west, where we typically see this nice pattern of recharge and discharge of groundwater. We've last couple of years we've had some kind of truncated recharge. We got a little more recharge this year than last. This kind of seems to be leveling out a little bit here, at least more slowly going down. Potentially a good thing. Then we've got the Davenport well in Lincoln County. I go back a number of years when I present this just to show this long-term trend where we had a low back in 2015-16 and significant recharge that's slowly been coming down since. And we've kind of at least had some better recharge over last year and maybe an upward trend. We'll have to keep an eye on that. I guess maybe the La Nina could help with that for returning to those conditions. Then the Whetstone well, again, back a number of years just to kind of capture a couple of these peaks in recharge. This isn't quite as responsive on an annual basis. Although we do see these small kind of recharge bumps. We've kind of just had one of those, and we'll just have to see if there's any significant changes or it kind of just rides this very low amplitude of recharge and discharge. Just to summarize then, the 7-day average stream flow at 8 index gauging stations are mostly normal across the state, with the exception of the Puyallup River and Hangman Creek over near Spokane being below normal. Cumulative runoff hydrograph for the state is sitting at normal runoff, and the monthly average groundwater conditions showing normal at Scatter Creek and Whetstone and below normal at Davenport. With that, I can take any questions or yield to the next speaker.
Cool. Thank you, Nick. Any quick questions for Nick before we head to Chris? I'm not seeing anything, but if anyone has anything for Nick, we can connect with him afterward. or at discussion as well, if you're still available, Nick. I want to say thank you as well for highlighting the piece that what you're sharing is not accounting for snowpack issues and where that snowpack will continue to affect stream flows coming more into spring and summer. And with that, we will go over to Chris Lynch with Borough of Reclamation. Thank you, Chris.
Okay, it's saying I can't share yet.
Oh, let me take out Nick's share here. There we go. Should be able to share now.
Okay. Okay, hopefully you can see
Yep,
a picture of Chinook Pass.
we see it. Thank you.
Okay, good. So this is an abbreviated version of our water supply update from early May. And this picture is from Chinook Pass. They clear this each year and we kind of keep track of it. It's at upper reaches of the Natchez Basin. And those are the toilet houses at the top of this pass. Okay. We release a press release, a news release each time we do our forecast, and it updates folks in the basin of the current water condition and a very brief version of it. Okay, now I'm going to get right into some definitions because of how it influences our basin and how we're operating. So I'm going to define natural runoff proportion. That's a period when we are using the flows that are naturally flowing into the basin outside of our reservoirs. So the tributaries that are below our reservoirs, and then also any incidental releases from our reservoirs. So that would be the natural runoff. And we try to just distribute that to the users as long as possible. So we're calculating a percent. So that's what the proportion means. So bullet by bullet here, the objective of the NRP is to delay release from storage and improve the water supply. So we're living off the natural available flow and holding back storage. NRP is voluntary, so our irrigation districts will respond voluntarily to limit their diversions to help stay within this natural runoff available. Irrigation diversions, again, I just said this, but it's the next bullet. Irrigation diversions are limited to the available supply. The available supply is incidental reservoir outflows plus unregulated tributary inflows. The available supply is allocated proportionately to the major irrigation districts. So basically, we look at what they're diverting and we see how the supply, how much water is available, and let them know what percentage of their full diversion they could get. And they've typically been below their allocation through the spring. And I will point out some of those on my graphs. Districts are informed approximately semi-weekly of the NRP percentage. So that changes week to week. So when things get cold and flows tighten up, the flows drop and there's less available. And when it gets warm and their flows increase, then the percent goes up. The NRP period ends when flows decline and demands increase, and we can no longer stay within the percent. And when that ends, pro-rationing begins. And so What that means is that we need to release water from storage more than the incidental releases. So it does affect our storage supply, even though they may still continue to fill, it limits to some degree the refill. And that day occurred yesterday. We got to the point where we did not have enough water to continue on NRP, and pro-rationing began. The other thing about beginning pro-rationing is it defines the period for which the irrigation districts can manage their allocation. So as of May 21st through the September 30th, they have a defined amount of water, and it helps them budget that through the season so that they can meet their users' needs in a flexible fashion, but it's a limited budget. So they have to do the budgeting, how they're going to use it through the season. So that's what happens when they go on pro-rationing. And that's why I'm defining this. And then folks may have heard of the storage control date. It's slightly different, or it can be a different date than the beginning of pro-rationing. It's when we start to draft the reservoirs. And we're controlling for the flow down at the Yakima River near Parker. Okay, now I'm going to go into our typical conditions slides. This is the airport in Yakima weather station. The top, you've all probably seen these kinds of graphs. This is the water year graph. Up in the top side, we have the temperatures. You can see that in January, we had a big chill, and then we were mostly near normal, within the normal band. Although we had a couple of pulses of warm weather, which helped loosen up the flows, melt the snowpack, and then it got generally cooler again. So we were cooler at the beginning of May, and then warm second week and cooled off again. That definitely affects the flows in the river. And this cooling is partly responsible for why we no longer had enough water available for just incidentally available for diversions and needed to release water from the reservoirs. Precipitation down in Yakima is right at about 92% of average. It's definitely been dry since early April. And this is a slide showing our precipitation at our 5 reservoirs. And we just update this graph monthly. So this was from the 1st of May. And it shows the percents of average for each month across the top here. And then the percent of average for the water year is 82%. And as has been observed in the other presentations, March and April have been dry. May has also been dry. I have a percent, I'm trying to remember if it was 53%. Anyway, in my summary, I have the percent of normal for May. I can't remember what it was. So, of course, we've been dry. Just a point of interest, and this relates to what Nick has said earlier. The spring, well, March and April were 9th driest on our 113-year record. And the last 10 years, we've had 7 below average spring, March and April. So 7 out of 10 of the last 10. It seems like we do go through trends where we in the early 2000s, we seem to have wet springs, and now the trend seems to be we're in the dry mode for spring weather. Okay, this is the snowpack in the basin as of May 1st. 59% at our sampled snow sites, and then here are the different subbasins from the Snowtell sites, 63% for the upper Yakima, 70 in the Natchez, and 44 in the lower Yakima. Okay. Borrowing from the NRCS graphics, to this year, the black line 2024, tracking below average, of course, as was, and this graph is showing 60%. Although this little blip here at the end is unedited data, they kind of fix this daily. There must be a station that's needs fixing. But ignoring that one, we also do track what years we're close to help us in our forecasting, and we're tracking at the moment near 2023 and 2004. So, well, those will help us in our forecasting. This is the reservoir system observed flows. This is what we're releasing from the reservoirs. And you can see that in mid-April, we began to release water. That first big spike there is for a pulse flow for fish to help them migrate out of the system. And the second big one is also for fish out migration. And we did another one in May, smaller one, and we're in the middle of doing one now. That last peak was more of a natural event, but we did just fill Bumping Reservoir, and that contributed to the added water there. Now, I talked about the NRP, and one of the points is that so this is the Yakima River near Parker. This is our control point for minimum flow. It's below the five major diversions, and it's just below the city of Yakima, just downstream. And you can see this big drop in flow here the past week, and we really we're heading toward our minimum flow and had to release water from our reservoirs, and that's what triggered the end of natural runoff proportion and the beginning of prorationing. So you can see that just the flows were not available to hold that together. And that was largely due to cooling and a drop in flow from diminished snow melt. Usage. This is a graph showing the usage. Since late April, usage diversions have been below normal, and they were picking up here in the last week, but with the reduced available water, a number of districts cut back, but even with those cutbacks, there was not enough water to continue with the NRP. So again, we triggered the prorationing period. And our reservoir system is well below full, 72% of average, and 65% or so full. So it's really has been a struggle to fill the projects this year. It doesn't look like we'll fill 4 out of the 5. We've filled Bumping, but the others don't look like they will fill. Now, this is the runoff forecast from May 1st.
Hey, Chris, can you share your
Yeah.
screen again? The slides seem to have disappeared.
Oh,
Oh, you're supposed to,
okay.
never mind. Might just be me.
Okay.
Thank you.
All right. Okay. Hopefully it's keeping up. I'll do a little pause before I start talking about the next slide. Okay, this slide shows our forecast. On the left column are the subbasins, and of course the biggest subbasin is the Yakima River near Parker, and that's That's what we base our total water supply on. And then we have the reservoir subbasins. And this adopted is what we adopt as the likely flow, but we also present the low end and the high end. And over here to the right, in the blue numbers, we have the percent of average that flow forecast is. And so the adopted forecasts were coming in the 70 and upper 60% range. And we do look at 5 different forecasts. Well, sometimes more than that. We did adopt our multiple linear regression program. Program forecast for this month's forecast. And this slide is the total water supply available estimate for May 1st for the period May 1 through September 30th. We have line items listed here on the left. And of course, let me direct your attention to the adopted column. The first 3 elements, values, are the supply side. So we have the runoff that we're forecasting on the first line, and then return flows, along with the actual reservoir storage as of May 1st. And that gives us a total water supply available of 1.813 million acre feet. We subtract out, in a drought year when there's pro-rationing, typically we just subtract out 76,000 acre feet that's left over in reservoirs at the end of September as a minimum amount that we need for getting through October. And we also estimate an amount of water that will flow past our control point at Parker, which is designated here as the flow over Sunnyside Dam. So that's the last diversion. And that leaves different amounts for irrigation. So we got the 1.537 total for irrigation, and subtract out the more senior non-paradable entitlements, leaving 628,000 acre feet. And we also are expecting to release some water from storage for lower river targets. So that will be this extra 15,000 acre feet. And it leaves an amount for the proratable entitlements. The total proratable entitlements are 1.145 million acre feet. And the amount available is only 54% of that. So that's the pro-rationing rate. And that's what we are, that's our current rate right now. Start as of yesterday, we started that. We will update that at our next forecasting meeting. And we define our target flows. We're at the lowest target flow of 300 CFS. We have some extra waters from acquired waters, trust waters, conservation. And that's what this 105 is. And it's divided into 2 general groups. Okay. Just a comparison from March, April, and May. Our pro-rationing rate in March was estimated at 72, but it's dropped each month. 72, 63, and now 54. I'm going to blame it on the poor precipitation that has occurred in the spring. Okay, if you haven't heard, we have a new fish passage project at Cle Elum Reservoir that's really state-of-the-art. It's a helix, and it has multiple levels, and that's what these words are here. So it allows fish to pass at these different levels. And this line, the graphic line, is the reservoir forebay, how it's designating how full the reservoir is and then where the lines split, that's our projection on how full it will get, and then it'll begin to draft here as we supply diversions. We were hoping to reach all levels this year so we could test all of them, but it looks like we'll only be able to test 4 of them, probably not the higher 2 levels. But this is exciting for us. We have seen fish pass out of the reservoir effectively and smoothly with it's just very, very excellent fish friendly passage project. Okay, Yakima Reservoir storage is at 675,000 acre feet. At midnight, 64% full and 75% of average. April precip was 57% of average. For if we don't get any more, so we might end up with the QPF that we're seeing. We may end up near 60% of average for the month. I'm sorry, I may over here on the right, 53%. I don't think we'll make it to 60%. Again, pro rationing is 54%. Just a reiteration of the target flows. We've released pulse flows and the helix. So that's all I have.
Thank you, Chris. And I'm gonna have a moment here for questions. If anybody has a question they want to physically or virtually raise their hand. And Chris, we do have a question for you in the chat. If you could go over again the relationship between the pro rationing date and the storage control date and briefly explain that once more and how they're not necessarily the same date.
Okay, yes. I'll try to give you the main point. I'm gonna share. Can you see that?
Yes.
Oops. Okay, so the reservoir level is this green line. This is this year's reservoir level. I'm going to focus on this right now. Okay, so there are two factors for the storage control that the flow at the Yakima River near Parker is being controlled to the minimum flow amount. So we are actively releasing water for that even now, but we're not on storage control yet because the reservoirs continue to fill. Once they begin to decline, then we will be on storage control. And I've been expecting it to occur around the 1st of June. So you can see, even on this red, that it began to decline around the 1st of June. And that's what will trigger it. Okay, now pro rationing begins when we actually have to start releasing water from storage, and it affects the actual storage, the accumulation of storage. So even though it's not yet declining, it's less than it would be because we're releasing water from storage. Okay, so that's the nuance there. I hope that answered your question.
Thank you, Chris. Jackie, any follow-up questions if you're still on the line?
No, that was so helpful. Thank you, Chris, for explaining that once more.
Great.
You're
Thank you,
welcome.
Chris. So, and for folks that have to go right here at 11:30, I just put a bunch of links into the chat here that are with their Ecology Drought Response page, as well as the last one is where you'll find this recording of the presentation once we get things up next week. I just want to take a moment and offer if anyone else attending has any other conditions or questions they want to share. Cool. Thank you, Nick. I'm not seeing any sort of virtual or physical raised hands, but I'll put my contact info into the chat. If folks have other questions here, And again, we do have our drought response grants available at this point in time. And some of the links I put into the chat does have more information on those drought response grants. So if anyone's representing any public entities or federally recognized tribes that are interested in those grants or have other drought relief questions, you're welcome to reach out and discuss things before applying. And again, thank you to all of our Wasatch committee members and presenters sort of bringing this full picture together and looking at all these different angles. We really appreciate your time.